First of all, I would like to thank the organizer for this opportunity to share with you my research theme, or this talk. It's about friction welding of dissimilar metallic material. My presentation is or contains those points: introduction, definition of welding, welding techniques, welding of dissimilar metals. The core of this presentation is friction welding processes and some case study. From the historical point of view, the process of welding is well known. For example, this picture shows us a part of a mask of Tutankhamun, which is welded. As introduction, welding is one of the most common joining processes in industry. Concerning the types of welding processes, generally we divide the welding processes in two types based on fusion process or non-fusion process. For example, the first one is the thermal fusion joining processes, which contains the conventional welding process like arc welding, or a new one like, it's not new, but considered as new compared to arc welding, which is laser welding. The second category or class or solid state joining processes, as example, is the friction welding or solid state diffusion welding. In this category, there is no fusion of metals. Welding of dissimilar metals. The reason why we use this the welding of dissimilar metals is the first one is to decrease weight. For example, we can change steel by aluminum, as it is shown in this figure here. For example, here this part is aluminum. It replaces the steel part. The second reason is for improving performance. For example, to choose two dissimilar metal, and each metal has his own properties. The second one is for the low cost. It means in some case we choose metal with low costs to weld with another metal with high costs, is to gain money. What is the industrial application of dissimilar welding? For example, as in nuclear power plants and oil refinery conditions. Example, low alloyed pipe connecting to valve of stainless steel. In certain nuclear power plants, there is approximately 20,000 valves. It means 20,000 dissimilar welded joint. In automobile industry, like this, as it is shown in this figure, and other uses like the battery, electronic industry, ship building, aviation industry. Now I will speak about the main welded dissimilar materials, not especially dissimilar metals. It means we can weld metal A with metal B, or polymer with metal, and ceramic with metal. For example, for the welding of dissimilar metals, it means we can weld steel with aluminium, steel with copper, aluminum alloy to magnesium alloy, aluminum alloy to titanium or titanium alloy, aluminum alloy to silver, aluminum to copper. But from the literature review, there are limited welded number of dissimilar metals. This is the first observation. What is dissimilar welding? For example, we have in general 2 cases, but in this case, in this example, I have presented 3 cases. For example, we can weld metal A with metal B directly. Second case, we can, this is related to the arc welding. It means we can weld metal A to metal B by adding the third metal between the 2 metals, between 2 dissimilar metals. In general, we use electrode. The case 3 is to put a thin sheet between metal A and metal B. This is as solution to weld metal A with metal B. However, welding of dissimilar metals poses challenges. It means it is usually more difficult to join dissimilar metals than identical metals. What are the obstacles? This is a question. The main obstacle is the difference between chemical and physical property of dissimilar materials. For example, difference in chemical composition and coefficient of thermal expansion of dissimilar metals can lead to the formation of brittle phases, cracks, residual stress, and corrosion. For that reason, we are obliged to choose the appropriate technique of joining of each couple of dissimilar material. For example, to join steel to aluminum alloy is not good to use arc welding, it's not possible. The appropriate technique is friction stir welding, which is considered as a solid state welding process. Example of incompatibility between the 2 dissimilar metals. For example, if we take example of iron and aluminium, for example, if we take steel with aluminium, in general, there is two characteristics. That the first one is the melting point. Melting point of iron is 1438 degrees Celsius. However, the melting point of aluminium is 660 degrees Celsius. It means the melting temperature of aluminium is less than steel. In addition to that the density of aluminum is third of that of steel, as it is shown in this table. Now, what are the techniques used to weld 2 dissimilar metals? In general, as it is shown in this slide, all techniques of weldings can be used to weld, to join dissimilar metals, but there is a challenge. It means you must choose the appropriate one. Now I try to explain the friction welding. Friction welding is a solid state welding process. It can achieve the joining of metals below the melting point. It means there is no fusion of metal. In general, there are 2 types of friction welding processes. there is a linear friction welding, and there is rotary friction welding. Concerning the linear friction welding, as the main process in this class, there is friction stir welding. Friction stir welding was patented by Thomas et al. In 1991. The Welding Institute TWI of UK did experiments initially on aluminum and its alloy. The principle of this process, the practical approach of friction stir is to use non-consumable rotating tool consisting of two parts, including a shoulder and a pin, rotational speed of the tool, a tool traverse speed, and vertical pressure on the plate during welding are the main process parameters of friction stir welding. For example, here this table presents example of dissimilar welding of dissimilar metals by friction stir welding. From the literature, I have found those dissimilar welded metals, which are aluminum alloy to steel, aluminum alloy to magnesium alloy, aluminum alloy to copper or copper alloy, aluminum alloy to titanium or titanium alloy, aluminum alloy to silver, magnesium alloy to titanium alloy, steel to copper, steel to titanium or titanium alloy, and coated steel to aluminum alloy. It means from this table there are limited dissimilar metals which has been welded by friction stir welding. Now, from the metallurgical aspect of friction welding, in general, the welded joint is formed by three main zones. The first one, for example, here the parent metal or base metal. After that, there is heat affected zone. After that, there is a thermomechanical affected zone. And the central zone is the welded nugget. Here we have a stir, it means a mixture between the two pieces after this process. Concerning rotary friction welding, as it is shown in this figure, rotary friction welding process one of the method as a solid state welding was developed from a friction stir welding, relying on heat input from the friction between the surface of the workpiece. In the rotary friction process, this basic principle of the friction process is illustrated in figure 1. One of the workpiece is kept stationary and the other workpiece is rotating to generate heat, which make the workpiece soften and lead them bond together. In general, there are the main parameter of rotation speed, offset pressure, and friction time. Those figures shows us example of welded dissimilar by rotary friction welding. For example, here we have a copper with aluminum. Here we have two different steel with low carbon steel with stainless steel. What are the advantages and of friction welding? Different type of, the first advantage is that different type of joint like boot, lap, T-joints, and circular can be welded successfully by friction welding. Second advantage is low setup cost and less training. The third advantage is easily automated. The fourth advantage is can operate in all position, horizontal and vertical, as there is no weld pool like in arc welding. Low environmental impact, no requirement, it means no requirement of shielding gas, it means eco-friendly. Low welding temperature, short welding time, it means in 2-3 seconds we can weld by friction welding 2 bar of steel. Low porosity, it means no defect. Heat affected zone reduced, as it is known that the heat affected zone in conventional welding is the critical zone. We must reduce it. Reduced distortion, the joint exhibit excellent mechanical and corrosion resistance properties. To be clear, I have put this table to make a comparison between friction welding and arc welding. For example, for the friction welding, the heat affected zone created by friction welding is not large. However, in arc welding, the heat affected zone created by friction welding is very large. The second advantage that in friction welding, friction weld doesn't require a filler, it means electrode metal to join the base metals. However, in arc welding, we need to use a filler metal. The third advantage, no hydrogen embrittlement or porosity. However, in arc welding, hydrogen embrittlement or porosity can be observed in the welded joint. The fourth advantage is eco-friendly joining process. However, in arc welding, there is image intense visible, ultraviolet, and infrared radiation, which is very hazardous to the welder. It touches the health of the welder. The last advantage is the easy process. However, arc welding is not easy process. Sorry. Here I want to show you the example of some case study of welded dissimilar metal by friction welding. For example, here is an example of welding of 2 dissimilar steels. The first one is X70 steel, which is ordinary steel with duplex stainless steel. The two steels are used in pipeline construction. Maybe in some case we can weld those 2 dissimilar steels. Here, this is microstructure of the X70 steel, ordinary steel, and this is the microstructure of duplex stainless steel, which contains 2 phases. What is the technique used to weld those dissimilar steels? Is by rotary friction welding, as it is shown here. This is the sample welded by the rotary friction welding, and this is the welded joint, which shows us the difference in microstructure between the 2 steels, and there is no defect observed in the central zone, which is in the welded joint. The second case study is welding of 2 dissimilar steels, also by rotary friction welding. And here we can observe the microstructure of the welded joint, which is affected by the rotary during the process, and there is like a deformation, plastic deformation of the grains. Here, the 2 microstructure, the first one shows us the welded joint after friction welding. It means there is heterogeneous microstructure. But if you apply heat treatment at 600 degrees during just 1 minute, we can make homogeneous of the microstructure in the welded joint. The third case study is friction stir welding of aluminum alloy to ultra low carbon steel of course by friction stir welding using lap configuration. This is steel with aluminum alloy. What we have observed that we observed a small thin film of intermetallic compound, which can be controlled by its thickness can be controlled by the speed of the movement of the tool. Now, in our day, we can weld metal to ceramic by friction welding, as it is shown in this slide, by rotary friction welding, which is not possible by other techniques. This table shows us the list of different dissimilar material. It means between ceramic and metal, like the little of silicon with nickel, little of silicon with iron, little of silicon with vanadium, and the rest of the dissimilar material. Now, the list of dissimilar metal, the number of welded dissimilar is very limited. As examples, some dissimilar steels, not all steels, has been studied or investigated. Steel with aluminium, it means some steels with some aluminium alloy, some copper alloy with some aluminium alloy, some titanium alloy with some steels, and the majority of those studies were done for industrial purpose. The question is, how about the rest of metals and alloy? Now, for the scope of our future research, most of the investigation is focused on limited dissimilar material, or in general dissimilar metals. The tribological corrosion and surface topographical behavior of welded joint are not discussed in the literature. No proper guideline in terms of mathematical theoretical model of welding material is available. As conclusion, the main challenge, the first point, the main challenge of welding dissimilar relate to the dissimilar material, relate to the different properties displayed by the different materials. The second point, friction welding can be successfully applied to joining dissimilar material. The third point, friction welding of alloys, plastic, composite material, etc., is having a huge scope for future research. Many points have not received enough attention in the previous work and need to be studied in future investigation. And thank you for your attention. And if there is question or questions.